Hello students, in this video we are going to solve the worksheet problems, right? So I hope you have got the worksheets with you. So let us start the first problem. A line L passes through the point A, 1, minus 1, 2. So the coordinates of A are 1, minus 1 and 2, and is parallel to the line R equals minus 2, 1, 5, minus 2, 1, 5 plus S into 1, 3 minus 2. Okay, so there is a line L, which passes through this point and parallel to this line. Okay, now we need to write down the equation of line L in the form R equals A plus TB. A plus TB. Now it's very simple. R equals A is nothing but the position vector of this point. That means 1, minus 1 and 2 plus T times. Now this is the vector which gives the direction for L, isn't it? Now since the line L, this line L and this line are actually parallel to each other, definitely I can use this is the direction vector, isn't it? This is the direction vector for the second line. I can use the same vector as the direction vector for the line L also. So that means I will write 1, 3, minus 2 here. Okay, so this is the equation of line L. To make you understand, let's say this is the line. This is the line. I am talking about this is the given line. Let's say this is minus 2, 1, 5, and it is parallel to the vector 1, 3, minus 2, right? This is the second line. Now I need the line L, this is line L, which passes through the point 1, minus 1, 2, isn't it? Now the position vector of this point is this. Now since I need a direction vector for this line, but since this line and this line are parallel to each other, I can use this vector as the direction vector for this line. So that is how I got it. I got this equation of line L, right? So line L colon R equal to this. Now I have seen many students make this mistake. What they do is they write like this. Let me just erase it first. Okay. Now when they are supposed to find the equation of line L, they don't write R vector. They just write only this, which is incorrect. Let me erase this also. Okay, so we have R equal to A plus TB. So you have 1, minus 1, 2 plus T times. Yeah, they write only this, which is incorrect. Or sometimes they write L equal to, that is also incorrect. You should not write like this. So you should write, it's like writing like say 3 plus 4x and saying that this is the equation of a line, isn't it? That is wrong, right? So you should always write R equal to. So you should erase this. You should write R equal to. Now of course I can name this line. I can write it as L, right? That is how you do it. Okay, now it is given that this line L passes through the point P when t equal to 2. Let's say this is the line L, this is the point P. Okay, so you get the coordinates of this point when t equal to 2. Now I told you earlier that for different values of t, you get different points on the line, isn't it? Now when t is 2, you get the point P. So substitute t as 2, you get R equal to 1, minus 1, 2 plus, when you put t as 2, then multiply, you'll get 2, 6 and minus 4. So you'll get 3, 5 and minus 2. So the question is find OP vector. So this is OP vector. But if they ask you find the coordinates of P, you should write like this. P is The coordinates of P are 2, 6, coordinates of P are 3, 5, and minus 2. But they are asking you the position vector of P, that is OP vector, that is 3, 5, and minus 2. And the next one is find the magnitude of OP, which is very simple. Square 3, so 3 square plus 5 square plus minus 2 square, which is nothing but 9 plus 25 plus 4, so square root of 38, so which is equal to approximately 6.16. So that is the answer, right? Fine. So let us go to the second problem. AB is given. AB vector is 6, minus 2 and 3, and AC vector equals minus 2, minus 3, 2. Fine. The first question is find BC. Now BC vector is nothing but BA plus AC. You can see BC, so start with B and end with C, and in between you should have the same point, BA plus AC, right? It's like writing, let's say for example, writing AD as AC plus CD, okay, or writing AD as AB plus BD, okay, or writing B D as BC plus CD, or writing BD as BA plus AD, like that. But since I have A, B and C here, I need to find BC, so I will write BA plus AC. Yeah, you may wonder why not use BD plus BC, DC, but there is no D here, isn't it? Okay, so let me erase this part. Fine. So BA plus AC. Now AB is given, so therefore BA is nothing but minus 6 to minus 3, isn't it? So BA is negative of AB plus AC is minus 2, minus 3, 2. So if you add them, you get minus 8, minus 1 and minus 1. So this is BC. The second part is find a unit vector in the direction of AB. Okay, that means first I need to find the magnitude of AB. So magnitude of AB is, I need to square each component and then add them. So 36 plus 4 plus 9, so which is square root of 49, which is equal to 7. So the answer is 1 by magnitude of AB into AB vector. So, sorry, AB. So which is equal to 1 by 7 into 6 minus 2 and 3. So this is the unit vector. That means this is the vector whose magnitude is 1 and in the direction of AB. And the final one is, okay, now the C part is, we have to show that AB is perpendicular to BC. Now as we have to show that AB is perpendicular to BC. Now if you recall, if you have gone through my earlier video, you will remember that if I have to prove that two vectors are perpendicular, then find the dot product and prove that it is equal to 0. So if the dot product is 0, then definitely both these non-zero vectors will have to be perpendicular to each other. So I'll find the dot product of AB and BC. So we have AB here and you have BC here. So let me find the dot product. That means I'll get 6 into minus 8. That means I'm multiplying this and this, plus I'm multiplying minus 2 and minus 1. That is minus 2 into minus 1 plus, and finally I'll multiply 3 and minus 1. So plus 3 into minus 1. So I get Just a minute, please. As you can see, you're definitely not going to get 0 here. I think the question is incorrect here. It is given that show that AB is perpendicular to BC. So I think it has to be show that AB is perpendicular to AC, not BC, in fact. Right? So AB is perpendicular to AC. So what I'll do is, then I'll find the dot product of AB and AC, not AB and BC. So AB and AC. So AB dot AC equal to, so I will, let me write AB again, 6 minus 2, 3. So 6 minus 2 and 3. So I'll find the dot product of AB and AC. Fine. So AB and AC, first 6 into minus 2, that means 6 into minus 2 plus, next is minus 2 into minus 3. So minus 2 multiplied with minus 3 plus finally 3 multiplied with 2. So 3 into 2. So you'll get minus 12 plus 6 which is equal to 0. Therefore AB is perpendicular to AC. Yeah, hence proof. The sum is over. Now the third problem. So let me use a black one. Okay, third problem. Let V be equal to, the vector V be equal to 2, minus 3 and 6, and let vector W be equal to K minus 2 and 4, where K has to be greater than 0. Now it is given that the angle between these two vectors is nothing but pi by 3. So the angle between them is pi by 3. Find the value of K. So let us use the formula cos theta equal to V dot W by magnitude of V into magnitude of W, isn't it? So that means cos pi by 3 equals V dot W is 2 into K plus minus 3 into minus 2 plus 6 into 4 divided by, now magnitude of V is nothing but square root of 4 plus 9 plus 36 multiplied with square root of magnitude of W is K square plus 4 plus 16. So we know that cos pi by 3 is half, so half equals 2K plus 6 plus 24 divided by, this will become, this will be nothing but square root of 49 is 7 times square root of K square plus 20. So if you cross multiply, you will get 7 times square root of K square plus 20 is equal to 4K plus 60, right? So let me square both sides. We'll get 49 times K square plus 20 equals 4K plus 60 squared. Fine. Let me simplify this further. So I'll get 49 K square plus 980 equals, so if I expand it, I'll get 16K square plus 3600 plus 480K. So finally you'll get, if you simplify, you'll get 33K square minus 480K minus 2620 equal to 0, right? Fine. So if you use the solver, students, you'll get two values of K. One is 18.8 and another value is minus 4.23. Now if you recall, it is mentioned that the K has to be greater than 0, so this is not possible. So this is the answer. The answer is 18.8. Yeah? Fine. Let us go to the fourth problem. Okay. A line passes through the point 4 comma minus 1. Let's say this is a line. It passes through the point 4 comma minus 1 and its direction is perpendicular to the vector 2, 3. So there is a vector which is perpendicular to the line. So it is 2 and 2, 3. Okay. Find the equation of the line in the form ax plus by equal to p. That means I need to find the equation of the form in the equation of the line in this form ax plus by equal to p. That means the Cartesian form where a, b and p are integers to be determined. Okay. Now to find the equation of any line in vector form, you require a point on the line which we already have 4, minus 1. We also need a vector which is parallel to the line. But we have got a vector which is perpendicular to the line, isn't it? So I need to find a vector which is parallel to the line. Now if this line and this vector are perpendicular, obviously this vector and this vector are perpendicular. Okay, so I need to make sure that what vector can I have here, so that when I dot product with 2 and 3 I get 0. For example, I have 2 and 3 here. So what should be the vector when I dot product it? I should get 0 as the answer. Okay, so there are many ways to find it. The best way is you interchange 2 and 3. That means write 3 and 2. Okay, swap the places, and both 2 and 3 are positive. So you change the sign of either 3 or 2. Let me take it as, let's say, minus 2, 3 and minus 2. Okay, so now if you find the dot product, you'll see that you'll get 6 minus 6, which is equal to 0. So I can take this vector as 3 minus 2. You may ask me, sir, can I actually take this vector as minus 3 and 2? Absolutely fine, in fact, right? Or can I take this vector as, instead of this 3 and minus 2, can I consider, let's say, 6 and minus 4? Because if you dot product this and this, you'll again get 0, isn't it? So can I take it as 6 and minus 4? Absolutely fine, you can take it, not an issue at all. But I'll take it as 3 and minus 2. Okay, I'll erase this. So I got a point, I've got a vector also. Now, so the equation is r equal to 4 minus 1 plus t times 3 minus 2. Now the next step is converting this into Cartesian form. So I'll write x as r vector as x and y, which means x equals 4 plus 3t and y equals minus 1 minus 2t. Okay, I hope you understood how we got it. So 4 plus 3t equal to x and y equal to minus 1 plus minus 2t. So I'll get t as x minus 4 by 3. Here I'll get t as y plus 1 by minus 2. So equate both. X minus 4 by 3 equals y plus 1 upon 2. So cross multiply, you'll get 2x minus 8 equal to 3y plus 3. So the final answer is 2x plus 3y equal to 11. So this is the answer, required answer. Yeah, very, very simple. I hope you understood this problem. So let us go to the fifth problem now, students. Fine. The following diagram shows the obtuse angle triangle ABC. So let me draw the triangle also here. So this is the triangle, obtuse angle triangle. So this is B, and this is A, and this is C. As you can see, angle B is this angle is obtuse. That means the angle B is more than 90 and less than 180 degrees. Okay. Now the given you AB, which is minus 3, 0, minus 4, and also B, AC, sorry, not BC, AC. AC is given, which is minus 2, 2 and minus 6. Fine. The first subdivision is find BA. As I mentioned earlier, BA can be written as 3, 0, 4, isn't it? If AB is minus 3, 0, minus 4, here BA is negative of that. So 3, 0, minus 3, 0 and 4. Okay. Next question is find BC. BC can be written as BA plus AC. BA plus AC. So we already have BA and we already have AC. So we just need to add them. So you'll get 3 minus 2 is 1, 0 plus 2 is 2, 4 minus 6 is minus 2. So BC is 1, 2 and minus 2. The next question is find cos of ABC. Now cos of ABC is nothing but BC dot BA divided by magnitude of BC into magnitude of BA. Okay, that means we use that formula, right? To find the angle between two vectors. So to find cos of ABC, this is what we need to do. Now we need to find the dot product of BC and BA. So it will be BC is here and this is BC and this is BA. So the dot product will give me 3 into 1 plus 0 into 2 plus 4 into minus 2 divided by, now magnitude of BC. Okay, magnitude of BC is 1 plus 4 plus 4 square root of multiplied with magnitude of BA is nothing but 9 plus 0 plus 16. So you will get in the numerator 3 minus 8 is minus 5 divided by, this will be square root of 9, so it is 3, and then square root of 25 it is 5, so minus 1 by 3. So cos of ABC is minus 1 by 3. Now the next question is find sine ABC. Find sine of ABC. Now we know that sine of ABC is 1 minus cos square of ABC. Square root of under root 1 minus cos square of ABC. Right? Now you may wonder, how did I get it? Let me explain it to you. Okay, let me erase this part. Fine. Maybe this also I might erase. Okay, fine. Now we know that sine square theta plus cos square theta equal to 1, which means sine square theta is 1 minus cos square theta. So which means sine theta is plus or minus square root of 1 minus cos square theta, isn't it? Either plus or minus, not both at the same time. But here you can see this angle B is obtuse, which means the angle B, the measure will be between 90 and 180. So if we look at the quadrant, it lies in the second quadrant where sine is positive, isn't it? Sine values of obtuse angles are positive, so that's why I have taken plus root of this. So I'll get square root of 1 minus, squaring this I'll get 1 by 9, so square root of 8 by 9, so you'll get 2 root 2 by 3. So sine of ABC is nothing but 2 root 2 by 3. Fine. Now the last part of the problem. Okay, fine. It's given that CD vector equal to minus 4, 5 and P. And it is also mentioned that the magnitude of CD vector is nothing but square root of 50. Then if that is the case, you need to show that the value of P is 3. So let me find the magnitude of CD, which is nothing but 16 plus 25 plus P square. So square root of this. This is the magnitude of CD. Now it is given as square root of 50, right? So let me square both sides to remove the square root sign. So I'll get 41 plus P square equal to 50. So P square is 9. So P can, and it is also mentioned that P is greater than 0, right? P is greater than 0. So P is plus 3, as P is, since P is greater than 0. Otherwise, we may write P as plus or minus 3. Now finally, you have to show that CD is perpendicular to BC. I have to show that CD is perpendicular to BC. How do you show that? Very simple. I find the dot product. So find the dot product of CD and BC. So that means I will dot product this and this. So 1 into minus 4 plus 2 into 5 plus minus 2 into P is nothing but 3, right? So minus 4 plus 10 minus 6, so which is nothing but 0. So since the dot product is 0 and both of them are non-zero vectors, definitely CD is perpendicular to BC. CD vector is perpendicular to BC vector. So this is how we solve this problem. Fine, let us solve the sixth problem, students. The line L1 passes through the points A. The coordinates of A are 1, minus 1 and 4, and the coordinates of B are 2, minus 2 and 5. Okay, the first one is find AB vector. So we know that AB vector is nothing but OB vector minus OA vector. So OB vector is nothing but 2, minus 2, 5, minus OA vector is 1, minus 1 and 4. So if you subtract, you will get 1, minus 1 and 1, isn't it? 2 minus 1 is 1, minus 2 plus 1 is minus 1, and 5 minus 4 is 1. Okay. Second part is find the equation for L1 in the form R equal to A plus TB. So I need to find the equation of L1, R equal to A plus TB. Now it is mentioned here that the line L1 passes through these points A and B, isn't it? So that means I can take this point to find the A vector. So R equal to 1, minus 1, 4. And since the line passes through A and B, I can take this AB vector as the direction vector. So plus T times 1, minus 1 and 1. So this is the equation of L1. So I can write L1 colon R equal to. Fine. And they given you another equation, L2 colon R equal to 2, 4, 7 plus S times 2, 1 and 3. Right? So you have two different lines, L1 and L2. So the third question is find the angle between L1 and L2. Okay, I'll erase the rest. So I need to find the angle between L1 and L2. Now we know the formula to find the angle between two vectors, isn't it, students? Okay, so we have cos theta equal to, now what I'll do is this vector gives direction to the first line and this vector gives direction to the second line. So I can take these vectors as A vector, I'm sorry, not A vectors, let's say some U vector. Already we're discussing about, so I can take it as, let's say, some U vector and V vector, right? So what is the formula? U dot V by magnitude of U into magnitude of V. That means the dot product is 1 into 2 plus minus 1 into 1 plus 1 into 3 divided by magnitude of U vector is square root of 3 multiplied magnitude of V vector is square root of, so if I square this 2, 1 and 3, I'll get 4 plus 1 plus 9, so square root of 14. So you'll get 2 minus 1 plus 3 by square root of 42, so which is 4 by square root of 42. So theta is nothing but cos inverse of this 4 by 42. So use the calculator. So I have kept it in the radian mode. So theta is nothing but 0.9056. So 0.906. So that is the in radian, 0.906 radian. So that is the angle between these two lines. The final one is the lines L1 and L2 intersect at the point C. Find the coordinates of C. Okay, so I need to find the coordinates of C. So let us do that. Fine. The first thing we should do is you should equate both the lines. So 1 minus 1 4 plus t times 1 minus 1 and 1 equal to 2 4 and 7 plus s times 2 1 and 3. 2 1 and 3. So for writing this step, students, you will get a mark. So it's very important that you write this step before you start solving the problem. Okay, let me erase this. So the next step is equating, getting three equations. So the first one is 1 plus t equals 2 plus 2s. Right? 1 plus t. So I hope you know how you got it, that 1 plus 1t equal to 2 plus 2s. So this will give you t minus 2s equal to 1. So I'll take it as equation 1. Now the second equation, minus 1 minus t equal to 4 plus s. So you'll get minus 1 minus t equal to 4 plus s. So this will give me minus t minus s equal to 5. So equation 2. And then the third equation is 4 plus t equals 7 plus 3s, which will give me t minus 3s equals 3. So equation 3. Now let me solve equation 1 and 2. So t minus 2s equals 1 minus t minus s equal to 5. So if I add them, you will get minus 3s equal to 6. So s is minus 2. That is sufficient. You need not find the value of t. Now the problem is not over, students. So after finding the value of s, you need to find the point of intersection. How do you find it? Substitute s here. That is the x coordinate. So 2 plus 2 into minus 2, which is minus 2. Okay. Next is 4 plus minus 2 here. So that means 2. And the third one is 7 plus 3s. So 7 plus 3 into 2. So 13. So the coordinates of C are minus 2, 2 and 13. Now if you recall earlier, I mentioned in the first video that when you solve, normally you will get the values of s and t as integers. Like, I'm not saying every time, but almost like 90% of the time you will always get the value of s as, let's say, minus 1 or 1 or 2 or 3, okay, or 1.5, like that. You will rarely get values like let's say 27 by 16 or 15 by 11, something like that. Okay, so if you do get it, then please make sure whether you have copied the question correctly, whether you have equated the correct equations, whether you have made any errors in simplification or not, right? So normally you'll get an integer value for s and t. So this is how we do it. So fine, I think it's only 35 minutes now, so we'll stop it here, students. Now the rest of the sums we will continue in this second video, right? Thanks for watching this video.